Hello, welcome to week 4. We're reaching the halfway point of basic soil science, PS101. It's Sunday, April the 7th. So, in about tomorrow, you'll be we'll publish all the courses and you'll be on your way. And of course, after this week, you're going to be hit with your midterm. And but I don't think that's going to be too big of a deal. Uh, I have on the screen an overview of week 4, and I got down here in the waiting room a PDF of the section 3, I believe it is, of the NCCER module on soils, and we'll go through that because I know you know how to read and you would probably understand this, but I want to make sure you hit on some points that you might see in other places. So I have a highlighted version coming up here in just a moment that we will go through together. Uh, take notes if you want. The week 4 tailgate, I think, is something I wanted to take a look at while I'm doing this video. Let me see if my mind is. Let's see, week 4 tailgate. Yeah, this is a video. Uh, the directions are a little difficult, and the actually doing it might be a little video. Really like the video. I'm going to click on it so we can look at instructions. Uh, this is actually an architectural, forget the association, it's for architect, and to learn about Soils 101. They have a series of online courses they can take and get prepared to pass the ARE test. I forgot what that architectural something test, but it's really good, little simple video to help us understand soils, their properties, uh, and their uses, and what's a good soil, what's not a good soil for foundations, and so on and so forth. Uh, um, what I did was I took a lot of notes. I really kind of liked it. Uh, and so what I did was pause and write down the things. There's some lady doing the talking, and I have seemed to have misplaced. There they are, my glasses. All right, but the main thing I want to do is make sure you understand the directions. This is a tailgate, and it's in the format of a tailgate. Uh, watch the video first. Every time she stops and talks about something, and or writes it down, or it shows up stop, and if I can't make you do this, but I would write those things down. It'll help you with your actual tailgate, plus it'll help you from now on. It's really some good stuff in there and not much of it. So the way I wrote these instructions, as simple as I could, though when I went back a little bit ago and reread them, I thought I'd better go over this. Excuse me. It says, after viewing the video, address the following points contained in the video. Excuse me. The points contained in the video name called Soils 101. I want you to do this in somewhat of a discussion format, even though I'm going to be grading you on what you know, as well as your grammar, your criteria that we have talked about. I need to go over that at some point, and I will. But remember, I'm going to grade you, look for things like, are you contributing to the learning community? In other words, are you saying things that would motivate us? Are you trying to stay interested? All of those kinds of things. It's just not something that I'm going to let you just write a bunch of things down and then that's okay. I'm going to look at it seriously and see if I can tell if you looked at it seriously or not. And if you did look at it serious, you should be able to write quite a bit on these essay questions in the other course that will dominate that course, uh, the excavation too. And since I don't think all of you are in both courses, excavation two and this basic soils, but a bunch of you are cross between them. Uh, so uh, let's get down to these this tailgate. Your initial response. Remember, I'm requiring my rubric, as I've said in the past, is designed that I in such a way that I need 3 responses from you, and your initial response is worth up to 35 points. Your first response to another student is worth up to 35 points. Now, the up to is whether or not it's any good or not, whether or not you really tried to be contribute to the learning community, or you're just passing through here. Uh, so your first response to another student will be, hold on, your initial response will be to answer the first question and talk about the particle sizes and the comparisons the video or she used to classify the sizes of the particles listed below number 2. What did she say to describe what a boulder was, what a cobble was, what gravel was, sand, like I remember silt, you can see the particles, but you can't pick them up. She used to, whether you could pick them up or not, to try to help you visualize it. And clay, you can't see the particles in clay, they're microscopic. Sand, she had a description for that. Gravel was the same thing. You could pick up gravel with the thumb and the finger. You pick up boulders with 2 hands. Those are the things that are in that video. You just pause it when you get there and jot those down, and you'll be prepared to talk about it. So that's your initial response. Your first response to another student will be to explain the factors that affect the strength of soils. The first thing that needs to come to your mind, in my mind, is water. That has a huge effect on many soils. The better soils, the coarse grained soils, it doesn't affect so much, but things like clay, the fine soils, it has a huge effect on that. There are other things that she talks about, that factors that will affect the strength of her soil. So just pause it, click on the screen, stop it, jot it down. And then your second response will be to answer question number 5. And it seems kind of weird, but I had a reason for doing it this way. I love this. The first time I saw this was the first time I taught this class. It said impermeable soils, and remember what permeable is. If you don't, I want you to look it up. It's important. Why is well graded considered bad, and why is poor graded considered good? I did not like that the first time I read that, and it's been a while since I taught this course. Probably hasn't been around up for a couple of years now, perhaps. But anyway, first time I saw that. But now, after I've been around a while, I've gone through the soils class and stuff like that, I understand what they're saying. Now I want you to uh, to explain what she's talking about. There's a word in here I told you to look up the definition, and the kinds of soil she's talking about uh, is well, you will see after you go through it. That's kind of a hint. So that's your tailgate for when you get to this week that we're in right now, which will be week 4. And I'm talking like you're you're just starting. But sometimes when I'm doing videos, I work ahead. So that's why sometimes it's you're not just starting Monday, like I said earlier. It just happens to be uh, you will have already started by the time you get here. Maybe that's the way I need to leave that. Now, let me go back to the modules, see if there's anything else before I get in here. This is reading material. This is not the one I want to use, I don't think. This is where I will put this video, will be here when I get through with it. Now, for the reading material and for the video's sake, I'm going to pull this guy up right here, and this is section 1 from the soils module. Let me get to the very beginning right here. I'm sorry, section 3 uh, in that soils module. The first time I did this, everybody had an NCCER book, the whole module. I did it this way because it loads quicker, and it kind of keeps. You can go through it, or I can go through it and present it quicker. So this is a really good module. I used to be an instructor in a certificate program, actually for a long time. I started in Oklahoma City back in 2005, I think, and was the training director there for quite a while. So when I saw this the first time I taught this, I really was learning shrink and swell and things like that. I hadn't been exposed to that much, and so I really didn't go deep into this, and that's why whether you came out as a certificate program or not, and whether you had soils or not, while you were in a certificate program, either Georgia or Oklahoma City, and even if you never had a course in soils, don't know anything about soil, it doesn't matter. We're going through this module, section 1 through 3, because when you leave here, when you go to your next opportunity, I want you to know something about soils. You know, dirt is our whole life. we're not we don't frame buildings. We don't we deal with dirt. So let's look at for section 3. It's called working in various soil conditions, and that's what week 4. I think I used this to for the name of week 4, and it says describe working in various soil conditions, the weight bearing and flotation properties of different soils. Weight bearing, solid rock would be your strongest as far as weight bearing. Flotation, what is flotation? That is how it stays on top of the ground. How in the world does a dozer stay on top of the ground? Well, it has to do with the type of soil and the area in square inches of your contact with either your tracks or the tires with the ground. Flotation is staying on top of the ground, and it's due to the square inches of contact that you have with the top of the ground and the kind of soil that you're driving or working on. Uh, how do the characteristics affect a machine performance? Well, right toward the end of this module, we'll get into some uh, clay kinds of soils and things, or talk about it, and how you have to get bigger equipment, and all of this stuff translate into productivity, not to exclude safety, but how much dirt can we move in a day and put it in the right place, you know. So describe the soil conditions that it can affect trenching safety. Well, water, that's the first thing that comes to my mind. And then when you have class C soil, it's coarse grain stuff. Coarse grain's good for upright walls and solid rock, but class C, their granular soils are not good for trenches because they tend to uh, slab off, cave in, etc., etc. So moving on, different soils have different characteristics that affect the operation of heavy equipment, and an operator must operate the equipment safely in different soil types and environmental conditions. You need to know how to use different types of equipment to overcome problems caused by different soil characteristics. We've all been in mud, we've all been in rock, perhaps. There are different ways to deal with that. There are three important characteristics that you need to keep in mind are these, the three important characteristics. Weight bearing capability of soil. Right down here, right quick, we have a little chart we'll use later. Weight bearing capability in pounds per square inch. Well, rock, semi-shattered rock, let's say solid rock, will hold up to 350 pounds per square inch. And if that's what you have with your weight, and when you divide your area, which is the square inches, by the weight, or the weight by the area, I forget which one, we'll get to that in a minute, that'll let you know whether it's going to stand up to this or not. So that would, where did I get resistance of a material to excavate? Did I say that? Uh, Different so the three characteristics, weight bearing, that was one, and I'll jump down here to that table right quick, and its capability of what kind of load can it withstand, the amount of traction a piece of equipment can get on the soil. They talk about a thing called coefficient of traction, and I don't think they know what they're talking about, but we'll mention it and give it a quick look and see if I know what they're talking about here in just a minute. So the amount of traction equipment can get on soil and the resistance of material to excavation, that's what led me to talk about you need to get big equipment when you're in wet clay and so forth. So the type of soil really does have an effect on your productivity and safety. So we'll talk about weight bearing and flotation properties, what they are. It is important to understand the relationship between equipment and the weight bearing capacity of the soil on which the equipment is used. The next section here, weight bearing, will explain that a little bit. So again, the weight bearing capability of the soil is how much weight it can safely support. It's related to the density of the soil. So when a soil density is low, meaning it is not well compacted, its weight bearing capacity goes down. It changes the game. Compaction is probably if not it's one of the most important activities on a construction site, on a dirt operation. So compaction increases the soil weight bearing capability and makes it more stable. Table 8, that's what we looked at a while ago. If you're in clean, dry sand, 27 pounds per square inch is all you're going to be able to hold up. Remember though, if you're in a dozer, your contact with the ground is really large when you take in consideration from sprocket to idler, front to back or back to front, and then the width of the track. That's a lot of square inches, so it'll keep you on you can stay on top of the ground in a lot of these. But now look up here in solid rock, and I used I'll show you what I used in just a minute. I used the area of some tires. I used like a haul truck, a 40-ton articulated haul truck, as their tires and their weight and things like that to come up. And the only thing that would hold it up with its payload would be solid rock. So that's the only thing it could drive on without, not necessarily sinking, but being hard to move. So this is just a chart talking about this material, and this is the weight bearing capability. I have a problem for that here in just a minute when we get into rolling resistant and flotation. Let's get through those. So let's see, pages are kind of hard to navigate. have to weight bearing capability is usually uh, let's see, measured in terms of pounds per square inch, PSI, but it can be measured in any terms of weight per unit of measure, such as pounds per square foot. The abbreviation PSI means the number of pounds that the soil can support on 1 square inch without sliding, excessively deforming, that means sinking, or collapsing. So figure 22 illustrates the concept of pounds per square inch. Let's jump up or down to that, wherever it is. Here it is, figure 22. See this guy, he's standing on blocks. He weighs 200 pounds. So the pressure on each box is 100 pounds per square uh, inch. Up here, he's on one box, one leg in the air. I don't think I can do that. But here it's 200 pounds per square inch because its surface area of that block is 1 square inch. But here you got twice the surface area. So it only has 100 psi on each one. That that's all the weight that the pounds per square inch that he's having to hold up. Uh, let's go read down a little bit. This is kind of the one thing about NCCER is their pictures and their words are not necessarily in the same location. The effects of soil conditions on machine performance. Soil conditions that affect machine performance include rolling resistance. A real quick look at that is we always called it soil that pumped. It's an elastic soil and it usually has water in front of it, but it rolls up in front of the wheel and it really makes a difference. It's like you're driving uphill, as the book said. That's called rolling resistance. And for cost analyses, you need to calculate that. And there's a table for that we'll get to in a minute. But let's get caught up with the description here. Rolling resistance is the resistance of the tires to movement. You've probably experienced having your personal vehicle sink in the mud or snow. In this situation, more power is needed to move the vehicle. The deeper the tire sink, the more power is needed to move the vehicle. This increases rolling resistance, and it seems that if the vehicle is always going uphill, but you're pushing dirt up in front of the wheels because of the weight. And this was where I got the area for 6 tires that are this wide in contact and in contact for this length. You know, they're rolling, so this always stays the same as they're moving. So let's see, I said that tires do not need, well, tires do not need to sink for the vehicle to experience resistance, rolling. When the road surface, let's see, I lost it, moves over it, it is, so let's see, the effect the same as sinking. Rolling resistance is measured in terms of, oh, here's what I want. Rolling resistance is measured in terms, let me find that, in terms of percentage of the machine's total weight. The effect of a rolling resistance of 20% is as if the vehicle is towing an additional 20% of, let's creep up here, of its weight, an additional 20%. And then it says table 9 shows some typical rolling resistance based on the type of tires or tracks and perhaps even the terrain. So let's go back down to table 9. Rolling resistance. If you're on very hard, smooth concrete, these are factors right here. In here, this is your resistance. I'll get to that in a minute. If you're on very hard, smooth concrete, cold asphalt, or dirt surface with no penetration, in other words, no sinking or flexing, and you have radial tires, your factor is 1.2%. In other words, it's whatever load you're carrying plus another 1.2% of that load. It's a little hard to explain, but let's see, if you go 20% of equipment and has higher excavation cost, it may, no, this is talking about the dirt digging. That we're kind of having to find our way here. But let's stick with this rolling resistance. So, real quick, I have a problem. I did it, it's a like a scenario, and it's about rolling. I have a haul truck that weighs 20,000 pounds. That's the truck with a payload of 40 tons. That's what's in the truck that he's hauling. So 40 tons is 80,000 pounds. The truck itself is 20,000. Or yes. So if he's hauling 80,000 pounds, 40 tons, and the truck weighs 20,000, the total haul truck and the payload is 100,000 pounds. So the rolling resistance in sand, let me see, or gravel, let's find that. Loose sand or gravel, right here, where, hope you can see it. And let's go straight across to radial tires. So the rolling resistance factor is 10%. So what you would have to do is to take that 100,000 pounds, that's what the total weight was, and to add an additional 10%, you would take that 100,000 pounds, multiply it by 1.1, and that would give you 110,000 pounds. And the reason you need to know this it would increase your fuel consumption, and it would take longer for you to move that. It's as if you had an additional 10,000 pounds on that haul truck. So when you calculate that, if you go by this chart here, which is pretty, I think Caterpillar puts this chart out, and it's not just a guess, it's just what they've determined. So we're going to try to keep the flow going and see if I can find flotation. That's the resistance in the soil that we'll get to next. This was about flotation. We'll get to digging resistance. Here, the ability of a tire or track to support the machine's weight on the ground is called flotation. To determine capacity, consider the total weight of the machine, including its payload, the contact area in square inches. Now, as you recall, this was my contact area. This was the length times the width, 8 inches. That brings up, and that brings it up to 104 square inches. They have 6 tires on them, so that brings it up to 624 square inches. So that's my area in my little scenario. But let's keep where'd it go? Let's keep talking about okay, so the ground is called for. To determine the capacity, consider the total weight of the machine, which we have at 110,000 pounds now, including its payload, which has it at 110,000 pounds. The contact area in square inches, which is 624 square inches of the tires or tracks on the ground, and the weight bearing ability of the ground. So you take the total weight of the vehicle is divided by the total contact area of the tires. I did that. I took the total weight of the vehicle, I divided 110,000 pounds, I divided it by 624. That gave me 176.2 pounds per square inch is what kind of pressure I would be pushing down from my load. When you go down here, what what kind of material could I work in? None but solid rock with that load. I couldn't work in this because I'm putting out 176.2 psi, which is greater than anything else on here other than solid rock. So I'd have to have uh, some pretty solid surface to move that kind of uh, load around in that kind of vehicle. So there's my spiel on flotation. Uh, it would have been better if I could have did this, but maybe I can put this up later, so by the time you get to here, you will have something to look at, more so than me just talking you through the values. So let's see, larger tires improve flotation because more tire surface is in contact with the ground. Reducing the tire pressure also increases flotation because more tire tread is in contact with the ground. So let's see. I want to go up, up, up. Let me make sure I'm covering all my bases here. I am. So that's the weight bearing. There is digging resistance. That's not the last thing, but close to it. Let's talk about digging resistance. So far, we've been talking about hauling stuff, moving stuff. All material has some degree of resistance to excavation. Some materials have more resistance than others. The type of material, along with its hardness, its cohesiveness, its weight, and degree of compaction determine its resistance. In other words, how hard is it to get it out of the ground? How hard is it to dig in? How hard is it to doze in? How hard is it to pick up in a scraper? So naturally, resistant material will require heavy duty, I'm getting to it, heavy duty equipment and higher excavation costs. It may be necessary to use a ripper, to break things up. And it shows a ripper down here and says, look at figure 25. And there's a ripper. A bucket with similar teeth like the one shown in figure 26. Let's see if I have a picture of that. Uh, no, I don't. It's here somewhere. I just hadn't found it. I just hadn't come across it yet. So there's the ripper. Rock is generally solid. It talks about how to rip up the rock. You can read about that. Uh, it goes into, there's the T right here, and have what they call slobber bits along the side. But they do have such things as rock teeth. They're forked and a bit more pointed than that. So hard digging, it talks about, doesn't require drilling or blasting. It's kind of defining the different kinds of digging. I'll let you guys read that for yourself. Then it gets into traction. And it says traction is the friction between the road surface and the tire or tracks of a vehicle. So it takes friction to take off. Like when you're in your car and you're on a dirt road, you step on the gas and it spins the tires, whoopee, off you go in a cloud of dust. Well, there's some friction involved there. When it gets traction, that means it catches and it starts to move the vehicle. But as long as you're spinning, you're not going to go anywhere, and because you have low friction. So low friction between the road surface and the vehicle tires allows the tires to spin without moving the vehicle, forcing some of the engine power to be used to overcome the spinning of the tire rather than to move the vehicle. Some of the things that affect vehicle traction are the surface material. Now, I don't know whether these guys were just trying to throw a big word in there, but a coefficient of traction. A coefficient of anything, which you will learn in soil when you start learning about the coefficient of curvature, the coefficient of uniformity. These are factors used in calculations uh, to to be found effective over time. Nobody just didn't make these up. So the coefficient of I had that written down somewhere. I wanted to read it to you. Uh, the coefficient. I wonder if what may have become of that. Oh, maybe I put it over here. Just so you know I'm not making stuff up. I'll read it to you. I know a little bit about friction, and there's static physics, and there we'll be getting into static physics, and then there's dynamic physics, which is moving things, and then dynamic physics they talk about friction a lot. So the coefficient of friction is the force that keeps objects from freely moving against one another. Uh, the, hold on, talk about the coefficient of friction. Now, the force that keeps objects from freely moving against one another is known as friction. In other words, when you go down a slide on the playground, there's very little friction, right? So you don't have much friction. But when you start grabbing hold of the side of the slides with your hand to slow yourself down, you start creating friction, which slows you down. The coefficient of friction is defined as the ratio of the frictional resisted force, the force that's pushing against you. In other words, like when your tires are spinning, your vehicle not moving, the force there's another force there that's not letting you go anywhere, and that's the mass of the car or the truck. It's not moving against you, it's just not letting you move. So you have a sum of forces of zero. You got the same thing going backwards that you do going forward, so you're not going anywhere. And that's the whole thing about static physics is all the summation of all forces in static physics have to equal zero. A guy standing on a stool has his weight pushing down on the stool, but the stool, though you can't see it physically exerting, is definitely pushing an equal force up vertically, or else they would fall, you know. So you got to have your sums of forces have to be zero and static. So that's it about coefficient. I'm not going to look it up, do like I do. Look it up. Don't make it up. Look it up. Tire treads and traction. Let's talk just a little bit about that. I don't think you're going to hear anything that you don't know here. The type of tread helps, of course, when you got mud grips and things. The capacity of the vehicle. What kind of tires do they have on the NASCARs? What kind of tread do they have on those tires on NASCAR? They don't have any. Next NASCAR you see race, I don't think they have any. And the reason they don't have any is because they want that surface area to be in contact with that asphalt of that racetrack. And they want a lot of it. They don't need mud grips. That's for when you're that's like cleats on the dozer or grousers on the dozer. I don't think those NASCAR drivers or Indy drivers have any tread on there because they're going around these corners and they need all the contact they can get. Let's see. We all know that times get hard. If you've ever stood behind a 90-pound one of these fellas for 8 hours, you know what work is about. 60-pounder is bad enough, but sling a 90-pounder around all day long and see how you feel that evening. But you still use these. Sometimes you're digging out utilities, and this is all you got. You're too close to the gas line to put an excavator arm down in there, so you get down the hole with the jackhammer. This is a little section on talking about sand, and it's been in several of their modules, but sandy soil collapses. We know that. But firm, dry clay and loam soils, if they do anything when they cave in, you crack. We will get into this a little bit more in the excavation 201 because we'll be looking for signs of these cracks as we're trenching or as we're excavating. Wet clay and loams just kind of glop off. I made that word up. And wet sands and gravels tend to slide Uh, I wonder if we would remember, which of these soils has the greatest weight bearing capacity? Dry clay, cemented gravel, compacted dry sand, medium dry sands. It says the greatest weight, I would say cemented gravel. That's gravel with Portland mixed in with it and set up and dried. Now, compacted dry sand is going to hold up a lot if you can contain the sand. You know, you can't just put a pile of sand down and build a pad. It won't stand up on its own. But if you put sand like in a ditch and then you're going to, or an excavation and you fill the excavation all the way up with dry sand and compact it on the way up in 12-inch lifts, you're going to have some solid weight bearing going on there with sand. Uh, a ripper is used to what? Loosen up compacted soil. A grouser shoe is used to improve equipment footing on muddy ground and traction. Compact soil that has been loosened by ripper. Wait, I'm getting ahead. This is a multiple choice. Grouser shoe is used to what? Improve equipment footing or traction. I think since they said grouser, it's traction. Okay, so you don't have to believe me. Which of these soil conditions is likely to cause a trench to fail by slabbing off? Which one of these? It set it up here. Slab off, wet clay, loam. Kind of makes sense. Okay, fellas and gals, if there are any, these summaries are pretty good, by the way. They won't do quite to get you through the test, but they are good. They do have good summaries of these things. So with that said, this takes care of week 4 as far as my investment or my work there. Uh, I'll have something up in week 5 maybe to help you be prepared for the midterm, but it won't be much. I don't think we'll have any other thing to do during the final or the midterm exam. The only thing that'll be in that module, I believe, it will be the test. There may be some review stuff in there for you. So with that, I know Monday's already come and gone. The course has already started. You've been in it for a while. But as far as this video, it's being made on April the 7th, 2024. And that's all for now, folks.